So we'll be solving this question today. Okay, I forgot to greet you guys. Welcome back, guys. Okay, let's move forward. So the question says that you are given a string containing n lowercase Latin letters. You define a substring as a contiguous substring of a string. For example, in a string, the substring this is a substring of this. That means from we can choose any index L and R. L should be less than R, and from L to R all the characters must be included. A continuous block is a substring. Okay, so you have to choose exactly one of the, okay, just a second, you have to choose a substring and then reverse the order to obtain a string that is less lexicographically, that is, and also it is not necessary to make it the minimum, we just need to make it less as compared to the original string. And lexicographically basically means when we for example, a dictionary is or arranged if there are words sorry, let me explain it clearly. If there are n number of words present, if we imagine that we'll sort it into a dictionary, that AA will come first, then AAA and all like that. So lexicographically basically means we'll sort it as a dictionary would. So in dictionary, this number, the string should be at a lesser index than the original string. For example, if the string is like TORN, okay, so okay, this is a bit complex, let me give a simple example. So let's say it was ABDC, so D has a higher dictionary index than C, right? So if we choose this as L and this as R, and we need, what we can do in one operation, we can reverse the entire substring from L to R. So when we reverse this, it becomes ABCD. So if we compare these two strings, ABDC and ABCD, the lexicographically ordered string, if we order them in lexicographic index, this will be lesser, right? Because the first index, which is different here, C is less than, sorry, just a minute, not, I have used the wrong sign here. So it will be less because the first character which is different, that is C here and D here, in this string C is less, right, as compared to D. So this whole string will be less as compared to this lexicographically. So that is what we have to do, that when we are given a general string A, B, C, D, E, F, G, H, let's say these are random like characters, okay, so random characters. So we need to select an index or a position L, and we need to select a position R, and we need to reverse all the substring that is present in here. So G comes in the place of C, C comes at the place of G, F comes at the place of D, D comes at the place of F, and E remains as it is. So we reverse the order, okay, from L to R we change it so that it becomes R to L, okay. So that is what each one operation does, and we need to find such an operation to make the final string after doing the operation lexicographically lesser than the original string, okay. So how can we do that? Let's say we are given this this example itself, okay, A, B, C, D, E. Is there any way in which we can change the order of this characters in such that we can obtain a lesser lexicographical string? No, right? Because this itself is the minimum present, right? If we say, for example, switch the last two digit, so it becomes A, B, C, E, D. So this is the first character which is different in both the strings if we go from left to right. So as D is less than E, so this, the first string, the original string will be less as compared to the changed string. So this is not correct. But if, let's say, this was the original string, this was the original string, there is a lesser lexicographical order possible, right? So if we check this as L and this as R, the last digit as R, and we twist the string, the substring, we keep all the remaining string as it is, and the substring from left to R we twist it, twist it or reverse it, whatever you can call it. So it becomes A, B, C, D, E, and the first character which is different from left to right in both the string here is, it is D here and E here. So as D is lesser than E, this will be lesser lexicographically. So yes, this is a valid operation where L is equal to the position, just a second, L equals to the position, this is position 1, 2, 3, 4, 5, L is position 4 and R is position 5. When we perform an operation with these two values, we obtain a lesser lexicographical string. Okay, so what we just need to do is that to obtain a lesser lexicographical string, we need, let's say there is an order, right? All the alphabets, all the character A, B, C, D, E to Z, right? All these have a value. Let's say I'll assign them a ASCII value itself. Okay, 66 and all. I guess it is 65 or 32. Just assume, okay, any number. So what we need to do is we need to bring a lesser number which is present towards the right and bring it towards the left. So a lesser number, see, D is lesser than E, right? Here the inequality is D is lesser than E. So this D and E, as this is D is lesser than E, we can switch it so that the lesser number comes forward, and once the lesser number comes forward, the string becomes lesser lexicographically, right? So that is what we have to do. We need to just find a pair, because a pair works, right? We don't need to find a long string. Like for example, if it was, let's say these are the characters, okay, I'll just represent them with dashes, okay, and if here D was present, here E was present, so, and all others are, let's say it is arranged lexicographically. Okay, so let's say I'll write A itself, A. So it is not necessary, as you can observe, we can perform this operation that L is equal to, these are the position 6, 7, so L is equal to 3 and R equals to 6, so we switch everything in between, so this whole part we need to reverse, so it becomes A, D, A, E, A, and yeah, this is also valid. Okay, this is also correct. This is a correct solution, because as you can see, in these both string, if we compare the strings, the first character which is different, we need to compare this. So D is, as D is less than E, this string is lexicographically lesser than the original string. So yeah, this is valid. But how can we but as you can see, finding a greater value and after that we're finding a lesser value, we need to find two index in this case, so it becomes a bit tricky, if you say. But as you can observe, if there is a lesser value present somewhere, that means a greater value is present before it, as what we can say also, because, okay, just let me rephrase. What I mean to say is, what we are doing, we are finding a part where this character is greater than this character. When this happens, we perform this operation that L is equal to this index and R equals to this index, and then we reverse the string, right? That is what we are doing. The reverse, don't get confused. Okay, so when we find a lesser number towards the right, we reverse the string to make it come towards the left. Okay, so we just need to find a pair itself. Only if we find a pair, that small L and R, that is the distance between the L and R, if we minimize it, if we just do a simple case, that is also valid. So in this case, instead of transforming this and this, because we need to find the index, two indexes, right, the 3 and 4, instead we can directly find it using only single index. How that we can I'll show you. So here E is present and here A is present, right? So in what is the inequality here? That E is greater than A. So yeah, we have found this, that there is some character, there is a pair where a lesser number is present towards the right of the greater number. So we can choose this as L, this as R, and we can switch it, and it becomes lexicographically lesser. So it becomes A, E, A, D, A. This, it becomes this. So this is a correct answer. So that is what we need to do, that we just need to find a pair where a character is greater than the character after it. A character is greater than a character after it. Okay, so the solution is simple, right? What is happening? Just a second, guys. I am not able to click. Okay, yeah. So the solution is this, that we iterate through the string, and when we find a character present with the value of the character is greater than, we can directly use the comparison sign to a character because it directly converts it into ASCII and compares. Okay, so when a character is greater than a character after it, so I plus 1 is a character after it, so if the character at I is greater than character after it, L and R are the positions this itself, that L is equal to this character and R equals to this character, and this, as this I is index and we need to report the positions will be index plus 1. So positions will be index plus 1, and when we find a pair, I just make the flag true and save that index, and finally print that value. Okay, else if I don't find any pair, then the boolean flag is false and I'll print no. So this was quite simple. So thank you, guys.